Now I will start with my part 1. Construct appropriate graph charts to compare the relative frequency and cumulative relative frequency between the two metrics. Before that, I will tell meaning of relative frequency. The ratio of the actual number of favorable events to the total possible number of events. Cumulative relative frequency, the proportion or percentage of times a particular value is observed in class interval or in any low class interval. This is the frequency, the number of waves the past and fixed point in unit time. So when we see the first chart is number of visits, we can see when the 10 up to 19 we don't have visit, but when 20 up to 29 we have 4 visits, and 30 up to 39 we have 26 visits. For the number of purchase, we can see at the second chart. It's 110 up to 159 we have 13 purchase. When 160 up to 209 we have 12 purchase. And when 210 up to 259 we have 5 purchase. So now we go to relative frequency. The formula I use is subgroup frequency divided total frequency. So the class 10 up to 19 we have 0 frequency. 20 up to 29 we have 0.1333, and 30 up to 39 we have 0.86667. Now this is the chart of relative frequency number of purchase. When we see at the class 110 up to 159 we have 0.43333, and when 160 up to 210 we have 0.4. And when we see at 210 up to 259 we have 0.16667. So now we go to cumulative relative frequency, number of visits. The formula I use is dividing the frequency of each interval by the total number of observation. When the class 10 up to 19 we have 0 cumulative relative frequency. When 20 up to 29 we have 0.1333, and 30 up to 39 we have 1 CRF. And for the number of purchase, we have CRF 110 up to 159 we have 0.4333, and when 160 up to 209 we have 0.8333, and when 210 up to 259 we have 1 cumulative relative frequency. And we must know when we search relative frequency and the cumulative relative frequency, for the last answer we must get 1, because when we sum all the relative frequency we must get 1.
Hi, I'm NORAINI and I want to present for part 2, which is calculate and compare measure of central location between the two metrics. For part 2, there are 3 things that I want to present. First of all is mean. The calculation is number of visits will divide into with the total of visits, and the final answer is 37.71. Then, for the number of purchase order will be also divide into the total number of purchase, and the final answer is 166.81. Secondly is median. The calculation for median is the number at the middle of data after being sorted according sending number will be plus and divide into 2 because it is even number. So for number of visit 34.1 plus 34.9 and got 96 divide 2, and the final answer is 34.5. Next, for number of purchase 163.3 plus 164.5 got 327.8 divide 2, and the final answer is 163.9. Finally, mod represent the value that appear more frequently in a data set. So for the number of visits, the mod is 34.1 appear 2 times in data set. And for the number of purchase order, there is no mod in data set.
Now we can graphically display or design the box plot to compare to or more distribution and to identify the outliers in a data set. The box plot contains 5 summary values, which is mean, max, first quartile, second quartile, and the third quartile. After we have found the summary values, we can calculate the outliers manually by using the formula given. First quartile minus 1.5 times with IQR, and third quartile plus 1.5 times with IQR. Any value that's smaller than this amount or larger than this amount is considered an outlier. Now we can graphically display or design the box plot to compare two or more distribution and to identify the outliers in a data set. The box plot contains 5 summary values, which is mean, max, first quartile, second quartile, and the third quartile. After we have found the summary values, we can calculate the outliers manually by using the formula given. First quartile minus 1.5 times with IQR and third quartile plus 1.5 times with IQR. Any value that's smaller than this amount or larger than this amount is considered an outlier. Now we can graphically display or design the box plot to compare two or more distribution and to identify the outliers in a data set. The box plot contains 5 summary values, which is mean, max, first quartile, second quartile, and the third quartile. After we have found the summary values, we can calculate the outliers manually by using the formula given. First quartile minus 1.5 times with IQR and third quartile plus 1.5 times with IQR. Any value that's smaller than this amount or larger than this amount is considered an outlier.
Hello, my name is JUMAIRAH binti DAMAT. My metric number is BT23303. So for the part 4 is measure of dispersion, which is include the range, mean absolute deviation, variance, standard deviation, and also coefficient of variation. So this is the formula when we calculate using the Microsoft Excel. And this is the raw data, and this is the ascending orders of visit and purchase. And this is the measure of dispersion of visit and purchase. From this we can see the purchase data had the higher of standard deviation, and we can generate that purchase had the higher risk of 31.43. The coefficient of variation. From this, the visit data had the higher of coefficient variation. So that means visit data had the greater the level of dispersion around the mean.
Hello, my name is IZZUDDIN SYAKIR in SURIATNO, and my metric number BB233060995. So I'm doing part 5, which is calculate and interpret measures of association between two metrics. For find covariance, first we must find the value of total variable x minus the total mean of x, multiply it by the value of total variable y minus the total mean of y. For example, total variable x is 53.8 minus the total mean variable x 37.011, multiply it by total variable y 199.4 minus the total mean variable y 166.82, and we got the total of 524.21. The covariance describes the direction of the linear relationship between variable x and y. The formula of sample covariance is total variable x minus the total of mean variable x multiplied by total variable y minus the total mean variable y divided by sample size minus 1. So we got total 5073.94 divided by 30 minus 1 equal to 174.96. As we can see, this is a positive number, which means this is positive linear relationship between two variables, number of visits and number of purchase orders. For correlation coefficient describes both strength and direction relationship between two variable x and y. For this, we use sample correlation formula, which is sample covariance divided by total standard deviation of x and standard deviation of y. So the solution is 174.96 divided by total standard deviation x and total standard deviation of y, which is 8.72 and 31.43. So the total for correlation is 0.64. As we can see, this is a positive number and it is close to positive 1, which means this is a strong positive relationship between two variables, number of visits and number of purchase orders.